Okay, in this example, we have y equals 3 to the x plus 1 plus 2. And here's your general form. Now remember, h goes right and left, k goes up and down. If I look here, my h is the opposite, so it's going to be -1, and my k is 2. So that means I went left 1 and up 2. But all I'm going to graph is the part that I circled. And because 3 is bigger than 1, it's a growth. So I'm going to use these 3 points, -1, 0, and 1. I plug in 3 to the -1, which is 1/3. I plug in 3 to the 0, which is 1, and I plug in 3 to the 1, which is 3. Now notice I plotted these points here and have a dotted line. Now I'm going to move left 1 and up 3. Left 1 and up 3. Left 1 and up 3. Now my final graph is this solid line. Now remember, the k determines my asymptote. So here is my asymptote. Domain for exponentials are always all reals, and because my k affects my range, it's going to be 2 and up. And that's how you do number 2. Another example. Now I'm going to look here. Is b greater than 1? The answer is no. But b happens to be between 0 and 1, so it's a dk. Alright, so there is no h and k, so we don't have to do any shifting. We are going to do a t-chart. And we're going to pick the points -1, 0, 1. I'm going to go -2, 1, 6 to the -1. Now if you want to, you can put this in your calculator, but we want to keep it as a fraction if we can. So -2 times 6 is -12. Remember, this -1 just flips this. Now we're going to take -2, 1, 6 to the 0 power. Anything to the 0 power equals 1. -2 times 1 is -2. -2, 1 6 to the 1 power is -2 over 6, which is -1/3. Now let's see what we have. Alright, so I'm going to graph this along here. And I'm going to go -1 and down. I realize I don't have a lot of space, so I'm going to call this -112. 0, -2, and 1 and a -3rd. And it is a exponential decay. Notice my k is 0, so this here happens to be my asymptote, okay? And now this graph is going to go like that. My domain for exponentials is always all reals, and my range is y less than 0. Alright, here's another example. I have an h and I have a k, so I'm going to write down h equals, remember it's the opposite, so h equals 3 and k equals 3. That means right 3 and this means up 3. We are only going to graph this part first. I do my t-chart. When I do my t-chart, I'm looking at -1, 0, 1. And I'm actually going to plug it in 2 times 6 to the -1. -2 times 1 over 6 is -1/3. -2 times 6 to the 0. -2 times 1 is -2. -2 times 6 to the 1 is -12. So now we're going to graph this. Again, you're going to do this on graph paper. I go over a -1, down a third, 0 and 1, 2. 1 and down to negative 12. My horizontal asymptote is here, so now I'm going to go like this. This happens to be an exponential growth, but it's a decreasing one. Okay, now this should have been dotted, and I apologize that I didn't dot it. Now I have to go to the right 3. 1, 2, 3, and up 3. 1, 2, 3. Right 1, 2, 3. Up 1, 2, 3. Right 1, 2, 3, and up 1, 2, 3. My horizontal asymptote is at 3. And this is now my final graph. So this is my final one. This one should have been dotted and it wasn't. So now my domain again is all reals. And my range is y less than 3. Alright, now what I have here is simplifying some expressions because in section 8.3 we actually learned about the letter E. It is a constant just like pi is, and we're going to treat it like we do with these rules. So to simplify this expression, you're just going to say e to the negative 5 plus 7, which is 4e to the 2. And that's what your answer is going to be. You're going to have about 4 problems like this on the test. So let's look at number 10. Number 10 says 5e to the negative 3, and it's raised to a negative 4x. We're going to now multiply these exponents. Now remember, 5 to the 1 has an exponent. It happens to be 1. So what we're going to write here is 5, 1 times negative 4x, and then e, negative 3 times a negative 4 is a positive 12x. Now you could simplify this as 1 over 5 to the 4x times e to the 12x. And that would be just fine. This one happens to be 6 divided by 1, which is 6. And we're going to take e to the x minus 5x. Remember, we subtract the exponents. So now what we get is 6 e to the minus 4x. We're not allowed negative exponents, so we're going to put it in the bottom. Now the negative only goes with the e. And so that's our answer. When you look at number 14, it's a little different because we now have cube root 125 e to the 6x. So we're looking at the cubed root of 125 and the cube root of e to the 6x. Now there's a couple of ways to look at this. I could look at my perfect sheet and I would find that that's 5. And I could also rewrite this as 6x divided by 3. So now I got 5e to the 2x. And that is it. Okay, this particular problem you're going to do on your calculator. So what you need to do is to get your calculator out. Let's see if you can see it. You're going to turn it on. Then you're going to go to y equals. I'm going to clear this out. And I'm going to put in negative 4 second e to the 2x. By now you should know where those buttons are. Make sure you put this in parentheses. And then I'm going to press zoom and then number 6, and there is my graph. And all I'm going to do is graph it like what's in this picture. So I'm going to put this over here, and on my paper I'm going to graph it. It actually goes like that. It is going down because of this negative, and I don't need any points. I mean, if you want to, you can get some points, and if you're going to put some points, you need to go over to the table numbers. So let's look at 0. if I put in 0, I'm going to get negative 4. So right here, this point is the point 0, negative 4. Okay, now you should be able to do not only all the review problems that I've assigned, and I will write down what those are.